Well, again, welcome. My name is Dr. John R. Taylor, and this is Math 1242, Section 007. Just to let you know, our class is on Monday, Wednesday, and Friday from 1:15 to 12:05, and we're in Fretwell 100. And I also have set up a review session that I try to set up for you guys, and we have one set up. The review session is every Friday. We won't have one this Friday because we only got like a short week here, but we're starting next Friday, following Friday, from 2 to 3:15, and we'll be in Fretwell 113, which is literally next door, but that's what I got reserved for us. This is Calculus 2, and if you've heard anything about Calculus 2, you heard it is the hardest of the calculus sequences. It's not just the nature of the material, because it's antiderivatives and the physics applications thereof. It's the volume of material that we cover in Calculus 2 that makes it so tough. So because of my large classes that I have, and we got 150 some people in here, I try to set up a place that you can go to for our class to get some questions answered, whether it be web work or other homework sets or whatever. So every Friday I've got it set up from 2 to 3:15 in Fretwell 113. I have an assistant in our class. This is Joseph. He's in the back there. He's my preceptor, so you'll be seeing him quite a bit. And we will be having assigned seats in the class, and he'll be taking roll. He'll also be heading up quite a few of those review sessions and working on web work problems and stuff. I will be coming in on quite a few of those review sessions as well and stuff, just to making sure you guys are understanding the material, and we'll also never know when a homework set's going to be due and stuff. And I'll get all that information down here for you guys as well. Again, here's my email address at jrtaylor@uncc.edu. My office is upstairs in Fretwell 335A, and there's my phone number. I have office hours on Mondays and Fridays from 12:30 to 1:30, pretty much right after this class, and Tuesdays and Thursdays from 11 to 12:30. Also, you can set up, if you can't make those, always by appointment, always works for me. We'll figure out a plan, your schedule and my schedule and stuff, okay? And we'll get back here to this particular site in just a second. If you click over here for syllabus, you will click on to our syllabus. You can also click right here with the syllabus and the course calendar, but I went ahead and printed out one, so here it is right here. So let's go through the introductions and what's expected in this class. Now, most of you guys took me for Calculus 1, and so the format's the same. Now, all you guys that had Calculus 1 last semester, you know we're doing the redesign, and the process is the same. And that process is you've got stuff to do before you come to class, you got to come to class and take notes, and you got stuff to do after you come to class. This is a very tough class. I'm not going to mix words on that. It is a very tough class, and it's for one reason only: the volume of material. You've got to catch a pattern on this stuff. So you can't afford to miss a class. Even though my videos are awesome, they're not as good as having me in person. So you want to be here and see my expressions on my face and stuff, and I want to see your expressions, and because we work together to get through this material and stuff. This, there's no reason why you can't make an A in this class, but this is going to be a time-consuming class. But if you look at Calculus 2 is the prerequisite for so many different classes out there, especially for you engineering majors. This is the class you got to have to be able to access all those engineering classes and stuff. And they're expecting you to know this material. It's that important. They're not going to go over it in your upper level classes. They're going to expect you to know it. And now from this, when you go into Calculus 3, and believe it or not, Calculus 3 is actually a little bit easier than Calculus 2. And the reason for that is Calc 3 is multivariable calculus. Once you understand the concepts of Calc 2, then we put it on a multidimensional plane. So Calc 3 is actually a lot of review of Calc 1 and Calc 2 in multi-dimension. So you see the same pattern over and over again. So when you catch patterns, it makes it a little bit easier. This one, well, we're going to have to show you some major patterns, and there's nothing to resource on it except your Calculus 1 skills. You've got to know your derivative skills and stuff. So our textbook is the same textbook as you had in Calculus 1, which is the Stewart Essential Calculus Early Transcendental book. I also recommend the Solutions Manual. That's always a great idea. And, of course, the 1242 Common Exam booklet that have the worked examples in there that If you look at the crappy handwriting, you'll recognize where the handwriting came from. I worked all those examples so you actually have something to study. So it's not just, yeah, here's a multiple choice question, the answer is A. I actually show you why the answer is A. So every problem, whether it be multiple choice or free response, I wrote up all those answers, and so that you can get at the bookstore as well, the final exam booklet and stuff. Again, I'm going to go through this rather quickly. Your job is to read through the entire course syllabus in its entirety, but our course procedures is the exact same course procedures as you guys had in Calculus 1, and that is this. This is that part of that redesign that we came up with. There's stuff to do before class, you got to come to class, and there's stuff to do after class. All right, before class, you need to complete the assigned reading and watch the awesome pre-section video that some idiot professor made for you guys. Yep, that would be me again. So watch the video and take notes off of it. Just don't watch and go, oh, it's very enlightening. No, take notes off of it. In these notes that we have, I've actually typed up the questions that I did on the pre-section videos. Okay, watch those things. Then, of course, you have to take the famous quiz, typically a 5-question quiz on that pre-section video, and you got like up to 3 attempts on that thing. And then after you do that, then come to class. And typically, I try to make these pre-section videos and the quiz due just before class time, okay? So I'm going to set the thing up so that just before class, and our class starts at 11:15, so by 11 o'clock, because that's a nice round number I like, I'm going to have the video, the quiz shut off. You're supposed to do it before you come to class. So the day that I start that material, now maybe some days I have to use one part of a class and then go over the next day in class. Whenever I start section, whatever it happens to be, you got to have the pre-section video quiz done and all that stuff, okay? Then, of course, you come to class, take notes off of the stuff, and I'll show you where the notes are located at. And then after class, you need to review your examples, and of course, there's web work to be done. We're a huge web work fan because also the engineering department uses web work. So your guys are not, for you engineers out there, you're nowhere close to being done with web work and stuff. So, and also, if you need some extra help, you can some extra learning opportunities. You can come by and see me at my office hours. Joseph will also have some office hours to be set up if you want to go see him. I will have a complete set of videos you guys can watch from previous semesters. Also, the Math Learning Center upstairs, 3rd floor, Fretwell, right across from the math department. We'll also have some SI, and I'll be announcing those dates. And don't forget the Academic Excellence Center also can set you up with 1 hour free tutoring per week. You got to sign up for it. First come, first served basis, but you can actually get one-on-one tutoring as well. The Math Resource Center, it's open tutoring. You walk in, you got a question, they'll answer it, and then the grad student kind of wanders around the room answering other people's questions, and you raise your hand again, and they'll cycle back to you, asking more questions and stuff. Okay? Test and test reviews. There will be 4 tests in this class. We have chapter tests. So Calculus 2, we're covering chapters 5, 6, 7, and 8. So at the end of chapter 5, and part of section 6.1, we're going to have test 1. At the end of chapter 6, we have another test 2. At the end of chapter 7, we have test 3. At the end of chapter 8, we have test number 4. And then we slap you with the common final exam. Very similar common exam that you guys took in Calculus 1. Comes in 3 parts. First part, multiple choice, no calculator. Second part, free response with a calculator. Second part, multiple choice with the calculator. Third part, free response with the calculator. So just like same format as you had before. But this will be your last common exam. When you get to Calculus 3, differential equations, linear algebra, so forth and so on, we start giving, the professor makes up the exam of each class. You don't have the common exams that we're analyzing the data. With these common exams and with the web work, you are being analyzed. We're trying to we show correlation between the work that you do on the homework sets and the homework you do on in the class and your grade in the class and how you did on, for example, web work and then the final exam and looking at the correlation between all this stuff because not just the math department's analyzing this stuff, we also give this information to the engineering department and other departments that request it and stuff. All right. Lecture and procedures professionalism. Please read through this thing. This is basically what we're expecting of you guys and what you pretty much can expect from me. I basically show the class on time, stay for the full class, and arriving late, leaving early is considered as absence. This is a partnership between yourself and myself, and these are the things that I expect. So please read through this, because I don't want to sit there and take all my time in just reading through this very large course syllabus. Lecture conduct and stuff. Most important, though, in terms of lecture conduct from you guys, is I do expect all computer services and web phones and computers and everything else to be turned off in this class. Unless you happen to have one of those tablet PCs you can write on and take notes off of, you don't need to be sitting there with the computer in the class. I mean, Fridays at the review session, that's a different story, because you want to work your web work. That's different. But while we're in class, you need to be working on the material we're doing in class. You don't need your computers open. You don't need your phones on. You don't need your iWatches. You don't need to be plugged in your ears with anything. You need to be 100% focused up here. This is where you're going to learn this stuff. You gotta be focused on this material. This class will earn you a good grade if you focus and really get this stuff down, because the key to math is catch a pattern. But if you get lost, this class will burn you. This is why you cannot afford to ever miss this class, because every day leads up into the next lecture. And if you're missing out on something or other, you're going to have a gap in your understanding, and that's just going to dwindle down and really affect you the rest of the time. You can't afford to miss this class, okay? Let's see here. Going over here in terms of course contract, here comes the big grade stuff, which you guys want to know. Obviously, this is college, so we're on 10-point grade scale. So 90 to 100's A, 80 to 89's a B, so forth and so on. Before class quizzes make up 5% of your grade. The test reviews make up 5% of your grade. Tests themselves, those 4 tests will make up 45% of your grade. Web work. It's not an option. After each section, we have web work homework to do, and we got some special web work for you guys, like a 1241 review web work and things like that. That makes up 15% of your grade. 15% is equal to one of your tests. It's not an option. It's required. You got to do it, and it's big point totals. You got to get the web work stuff done. Don't procrastinate. Procrastination kills with this stuff. Okay, you got certain due dates on this stuff, and you got to get it done before that due date. And of course, the ever-loving, God help you, cumulative final exam. That will be on May the 2nd. And thank goodness the registrars found the error of their ways, and we went back to the 3 o'clock exam session. So we'll not be taking the exam in the evening anymore. It'll be in the afternoon. So pretty much from 3 until 6 is when the exam is going to be, which is what it was supposed to be last semester, but at the last minute they changed it. So, and we'll talk more about this, but it's the same format as what your Calc 1 exam was, 3 parts, okay? And so, and therefore, in terms of calculator, again, I will be using my TI-84 calculator, and so that's typically what I expect you guys to have, TI-83 or TI-84. TI-89s and TI-Inspires are no longer allowed to be used in the classroom and on tests and stuff. And for a simple reason, the new TI-89s and the TI-Inspires have this interesting download capability. So you can actually save PDF files in your calculator and stuff like that. You know, save your homework set completely worked out and stuff like that. Well, shoot, you're supposed to be taking a test. And if you can access your old homework to see how we did it before, we call that cheating. So we decided, well, the easiest way, instead of having to go through everybody's calculator and basically every time we have a test clear it out, we just won't allow that kind of calculator in the class. So I'm going to be using a T84, so you can follow along with the buttons. If you got a 83, perfectly fine. The only difference between the two is the 84 is the upgrade. It has a little more memory on the calculator. But in terms of that, the buttons are pretty much in the same location stuff. All right. Attendance policy. Well, pretty much all you guys, which is looks like most of you guys had me before last semester, pretty much the same attendance policy. And there is an attendance policy. This class does have an attendance policy, and attendance it would be taken every day. That's one of Joseph's job. We will have assigned seats in this class. But for the first week, we'll just basically get you guys set up. So starting next week is when we'll try to get your particular location, and Joseph's going to have a kind of a template layout for the entire class, and he'll be taking your attendance accordingly. Okay, like I said, there's an attendance policy. We'll take There will be no unexcused absences in this class. You should obtain and keep documentation for every absence. However, I will only require you to file documentation with the Dean of Students after your third absence. Okay, so because, the key to it is you got to be here. I mean, if you're missing class, if you miss because you got a cold or something other like that, if you're first or second, call me. You're okay. I mean, I'm not going to make you go out there and fill out documentation of which doctor you had and fill it out with the Dean of Students and stuff. But by the time you start by the third or fourth absence and stuff, you've been missing too many classes. You either got a real problem with the cold or whatever, and you need to be able to document this thing, okay? And the reason for that is this. Starting with your fourth absence, your grade in the class will be lowered by 5%, and that for each additional absence. In addition, the benefits will be awarded for good attendance. Students with 2 or fewer total absences may replace their lowest test grade with the final exam grade. Now, if applicable. And what that means is, let's just assume you didn't do worse on the final exam as you did on any test in here, because that would be a real shame. But the fact is, based upon attendance, I will allow you guys to have your final exam replace your lowest test grade. And for you guys that had me for Calculus 1, I did that, and it really helped out quite a few people in my class. I see some people in here that probably wouldn't see otherwise. So it is a great thing, but I'm holding your feet to the fire. I'm trying to force you to receive this awesome award. You got to come to class. So 2 or fewer, you get to replace your lowest test grade. And trust me, there's always one test, and hopefully there's not more than one, that you wish you did better on, and hope you replace your final exam with that, okay? Okay, I also, with the final exam grade, I'll drop their lowest before class quiz and some web work. So I will, towards the end of the semester, I will be putting in some extra little bonus things because there's lots of web work to do. And there's obviously for every section, there's a pre-section quiz to do. And so at the end, I'll at least drop one web work assignment and one class quiz and maybe a little bit more. I don't know. We'll see how the class goes throughout. But I'll put in some extra bonus stuff for you guys. But the big one, and I'm going ahead and announcing it now, is I'll allow the final exam to replace your lowest test grade as long as your attendance is 2 or fewer. Okay, absences, that is. Okay. Communication policy, main deal on communication is we do everything through Canvas. So, and if you look at your Canvas site over here, and here it is, I will make the announcements right up here up front. So I try not to hide them anywhere I will occasionally send you a Canvas email, but those are typically rare. If I'm going to announce, say, hey, the test is going to be, and I usually give you at least a week out on that, I will post stuff right here, so it's right in front of your face in terms of announcements. So always check your Canvas site for information and stuff. So, and of course, you can come by and see me. You can also email me. That's fine. And again, please read through this entire syllabus because I've really tried to go out of my way to be more specific on it. But again, I'm just doing the glossing over of the syllabus for your benefits and stuff. You know, the idea of inappropriate comments. So I can go in hours talking about inappropriate comments from last semester. Dr. Taylor, I know I got a 52 average. Can't you give me a B? No, I can't give you squat, dude. All right, so that's an inappropriate comment. I had tons of them last semester, and I'm trying to say what some of you guys don't realize what inappropriate is. Asking for curves is inappropriate, especially after I give you all this bonus stuff. This is a college contract. Remember that. All right, additional learning opportunities. Like I said, you got walk-in tutoring at the Math Learning Center. We will have SI, which is also ran by the University Academic Excellence Center over there in Covart. They also have one-on-one tutoring. We have my office hours. You can come by and see me. We also have Joseph Preceptor hours. You can come by and see him. Makeup and late work policy. It's pretty simple. Because I record everything, I don't accept late homework and stuff. Because once I record it and show you what the answers are, after I hit end, it automatically throws it up to the web and everybody can watch it. So the answers are out there. So if the answers are out there, I can't accept late homework. You got to get your stuff in on time. Remember that. Don't ask, hey, can I turn this a little bit late because I just can't make it? No, you got to get it in on time to me. So no, there is no makeup for test. I will skirt if there's a legitimate excuse and you've got documentation that you really did have the flu or whatever case may be. we'll always make a plan. I mean, if, God forbid, your grandparents died or something or other, not a problem. I mean, I am human. I will make a plan. But I'm just not ready for taking that test, Dr. Taylor, because it's hard material. That's not an excuse. You got to keep up with the course and stuff. So there are no makeups for tests. You got to be here on test day. Do your best. If something unforeseen happens, come see me before the test. We'll make a plan. Okay. Tardiness. Again, classic. Be on time. Arriving late, leaving early, be counted as an absence. Again, Joseph will be in charge of all that stuff. Assignment standards. Please read through this. Remember, when you turn in stuff, be proud of it. Staple it appropriately. Put your name on it. Be neat. Be organized. Print your name so that somebody can actually read it. Take pride in your work when you turn it in. Okay? Electronic devices. Again, this is college, and in a class of this nature, you should basically need to put all your electronic devices away. You turn off your cell phones. You get the stuff out of your ears. You don't need a computer. The only electronic device you need in this class is a calculator. So for the 50 minutes, Monday, Wednesday, Friday that we're in class, your focus should be 100% up here. Okay. So again, academic integrity. I pretty much copied the stuff out of the book, but the same idea, academic integrity in terms of notes, web work and stuff, test. Please read your UNC Charlotte handbook about what considers cheating and the like, and don't do it. Disability accommodations, if you are needing some, you have some paperwork for that, go through disability services. They will contact me, and they are big into computers and paperless nowadays, so we'll get you covered and stuff. Caveat, I may modify the standards requirements or anything on my syllabus, because here's the real deal. Learn about college. I am your professor. I am Dr. John R. Taylor, otherwise known as a dictator. This is my class. I am in charge. However, I'm a benevolent dictator, okay? We'll make a plan. We'll see what we can do. But at the end of the day, my word is final in any professor's class. They are the dictator. They are in charge of that class. You have to go to their standards. We don't bow down to yours, okay? So remember that in terms of I can change anything I want to, but this is my contract to you. This is pretty much what I want to do. And if I change anything, it's going to be probably for your benefit, like pushing back a due date or something or other, and just hang with it. All right. Here's the course calendar. Now, I put that at the end of the syllabus. Now, if you guys had me for Calc 1 last semester, I had your Calc 1 class. I had 2 sections, pretty much same day of the week. They were just different times. So I combined everybody into the same class. But this semester, I've got 2 classes. I got a Monday, Wednesday, Friday class. I got Tuesday, Thursday class. So I've kept your Canvas page separate. So everything is literally separate this time, because adjusting the Monday, Wednesday, Friday versus a Tuesday, Thursday, things don't quite match up as well. So today, I'm supposed to go over syllabus and go in section 5.1. And I try to give you a day by day of what I'm doing, what it is, when I expect the test, when the review is going to be, so forth and so on. This is tentative, so please remember that. And I reserve the right to, instead of having it on Wednesday, I may push it back to Monday or something. I reserve the right to do that, basically, for your benefit and stuff. But this is a tentative, and I use that word very lightly, schedule, so you at least know what order I'm doing stuff. So I try to write this stuff up. And again, you guys in Calc 1 who had me last semester realized, yeah, pretty much after day 1, the course calendar was shot, and we kept having to redo it and stuff. It's just the nature of the beast. And you never know when we're going to have either a hurricane or a snowstorm or whatever, so that really kind of messes up everything around here. So a very tentative schedule. All right. So, again, before I get into the big notes of the day, last thing I want to do is just go over the Canvas page real quick, and then I'm going to get into the notes here. But for our Canvas page, the real deal is under modules. That's where I have everything listed. So the first thing you'll see is course information, and You know, we have the class recordings and stuff. This set of class recordings is actually an old complete set of the things. So if you want to get ahead, knock yourself out. There's some of my videos that I've already taught this material. You can actually read ahead and jump ahead if you want to. Some old common exam stuff I've got here. Here is the departmental common syllabus, so you can see how my 8-page syllabus compares to the 1-page syllabus of the department and what we're supposed to be covering and stuff. But most important is course requirements, the supply list. So listen up, because this is where we hit it, in case you want to know. So when you click on supply list, what are you expected to have? TI 83, 84 calculator. No Inspires and A9s are not allowed. 3-ring binder, because that helps, because here are the notes. Now, one little thing. You're in one of the Taylor's classes. You guys know that myself and my wife teach calculus here. And we're trying to do something special with the notes, but you're our guinea pigs. So we have special notes for you guys. No, not that much special. It's the same ones as everybody else, but we put some extra problems in there. And the extra problems are, we're going to put a little section called Algebra Review. The algebra that you need to remember to be able to do this particular section of Calculus 2. It's just a couple of very simple problems, and typically I won't cover this in class. If I do, I may start class just a little bit early because it takes about 1 minute just to remind you what the algebra is, because this class, starting at, well, in our case, 11:15, is when calculus starts at. So if I get a little bit early, I may just go over just a little bit early. So if you're a little bit can't get here a little bit early, don't worry. I'm videotaping it, but I'll just show you what the algebra is before we start the calculus section, and I do that for each section and stuff like that. And so here's the notes. And right now, I've only got 5.1 through 6.1 up. We just finished the notes today. And so I will be redoing a link on this one, which will allow you to have the entire set of notes that we're going to go over. Yeah?
Will you send them to the repress place before?
I will. However, and we're doing that today. However, you are in one of the Taylor classes. So it's a special set of notes. So when you go, there, you know, there's a print shop, you know where Chick-fil-A is, down below Chick-fil-A, right next to the post office. There's a little print shop over there, and they will print you guys out for a price. Welcome to UNC Charlotte. For a price, they'll print you out a complete set of notes and put your little holes in it so you can go have a complete set. If you want to print them out yourself, knock yourself out. That's why I'm giving you the PDF for it. But you have to ask for, I need one of those special notes from Dr. Taylor. And they will get you the special ones that have the extra stuff in there in terms of the, and all it is every little section has a little bit of algebra review that we're putting in. I want to check out, see how this goes. Just remind you of the algebra, because it's the algebra that tends to burn people in this class quite a bit. So we're trying to give it a little insight to the algebra here. So, yeah.
When will you upload the whole notes for the whole?
Probably this afternoon or this evening. Yeah. So, worst comes to worst tomorrow morning. Depends on how my day goes. But I'm shooting for getting uploaded this afternoon. All right. And so there, and then back to the modules over here. That's under, of course, supply list is where it's at. 5.0, this is the review. There's before class activities. Well, there's not much on the before class activities, except I gave you a complete set of Calc 1 notes. Here are the videos for Calc 1 in case you forgot all your Calc 1 stuff. All right. And then there is a quiz in terms of activities and stuff like that. There is a quiz on this particular stuff, and here's some information about web work, and there's web work for this stuff, and there's trig identities because a lot of people forget the trig stuff here. Okay. And so, and here's where calculus really begins, and we'll start here right now. Section 5.1, areas, and see, there's the 29 points here. You got a web work set here, but okay, section 5.1, before class activities. You were supposed to pretty much print out the notes, come to class, and then watch the pre-section video, and then take the quiz. But this is the first day of class, and people are going to try to join in our class like they do every semester, and I'm going to have a bunch of people that are going to be late ads, okay? So I don't make anything due officially until after drop ad. So right now, everything is open and nothing is going to close on you until, looks like January 22nd, okay? That's the last day of drop add. So this is why, so you got some time, but again, procrastination kills in this class. Don't wait. Go ahead and get the stuff done. And then come to class, take notes, and then after class, you got web work section 5.1. You need to go ahead and click on the web work, because that first time you click on web work, it kind of registers you in being part of this class and puts you in the roll book and stuff. Now, here's the deal, just like before. We have a grade book on Canvas, but the grade report back system from WebWork back to Canvas, Canvas has a problem with that and is not reading the grades correctly. So we had to break that link. So after chapter 5, I will import the entire set of your WebWork grades in there. You'll get your WebWork grades, but it won't show up in the Canvas book until after we do chapter 5, because I'm just going to import this stuff one time, because I'm going to do it for the entire class. So don't panic when you look on there. I know I did section 5.1. It says I got a 0. No, I haven't imported the stuff yet, so Canvas has no information about what your grades are. The grades will be stored in WebWork. So if you want to know what your grade is, it's going to be in WebWork. Go look there, and then at the end of chapter 5, I'm going to go and import, after each chapter, the stuff back into the Canvas gradebook from WebWork, but I have to do that manually. It's a computer system problem. And you do this concept of before class activities of watch the print out the notes, watch the video, and then take the quiz. And then after class, come to class, take notes, and then after class you got web work and stuff. You're going to do this for every section throughout, just like you guys did in Calculus 2, Calculus 1. All right. So let's go ahead and get started in terms of section 5.1. Now, first part is, we in terms of your notes, we just wanted to remind you of all the things you learned in Calculus 1. So here is a complete formula sheet of just basic derivatives, from basic forms, product rule, chain rule, course rule included, logarithmic, exponential, trig forms, and inverse trig forms. So if you forgot, go back and remember the forms and formulas. Also, some forms in terms of limit, limits, the direct substitution, the L'Hopital's rule, the simplified factor, and the limits of infinity, and the polynomial rule stuff. And so this is basically a nice quick cheat sheet of what you guys did in Calculus 1. So it's nice to hear and look over in case you haven't been studying that much over Christmas or whatever. All right, so here is section 5.1. Now, if you remember, the last thing you covered, for most of you guys, but in Calculus 1 was section 4.9. Section 4.9 introduced the concept of the antiderivative, or what we called integral, doing derivatives in reverse. We're coming back and we're going to hit you hard on that. But we're going to tie it in to its geometric representation. So this particular section 5.1 is on areas, area and distances, what we call Riemann sums. Riemann sums. You guys are going to go, oh, get scared by that word. No, it's a format. Riemann came up with this idea of trying to figure out the area under the curve. Now, this is what we expect you guys to do on each section. Every section we have before class video examples. The stuff that I did on the video, I put them in notes. So I want you to watch the video, but not just watch it. I want you to follow along and study and copy what I did on the video to catch a pattern. So I did problem 1 and problem 2 on the video. This is that new little section. So you have to do this before you come to class. And to get a complete set of notes, you need to watch the video and take notes off of it. This is the algebra review. This is that new little section that we put in there that's different from the other people's notes and stuff. And that is this. All right, for the function f of x equals 3x squared plus 4, find f of 0 and f of a half, because that's the algebra you're going to be doing this section. In case you forgot your basic rules, well, let's not hurt ourselves. F of 0 means what am I going to do? I'm going to plug in 0 for x. That'll be 3 times 0 squared plus 4. That's equal to 4. And then f of 1/2, this will be 3 times 1/2 squared plus 4. Now, each section has its own little different kinds of algebra techniques you need, but for this section, this is the only algebra you need to remember. Well, 1/2 squared is 1/4 times 3. That makes it 3/4 plus 4. That becomes 4.75. And for you people that just love fractions, 4.75 is also known as 19/4. We'll take it either way. And web work takes it either way, by the way. It takes decimals or fractions, so it's up to you. Okay? So, and you'll see in a second what the deal is. The other part of the algebra review is the area of a rectangle, because this is what Riemann did. If you watch the pre-section video, you kind of have a clue on this. Riemann tried to figure out the area under a curve by putting in little bitty rectangles. What is the area of a rectangle? The area of a rectangle, of course, is length times width. So in this particular rectangle, now use your math abilities. What is the length of this particular rectangle? What's the length? Between 5 and 10, what is the length here? 5. What is the height or the width here? How tall is it? 20. So 20. So the area is going to be width times length. So that's 20 times 5, which makes it 100. And that would officially be 100 units squared if y'all want to really talk about, the physics behind it. Don't forget your units and stuff. But the answer is 100. Length times width. Because I'm tying this stuff into what Riemann did. Riemann sums. Riemann sums is a technique of estimating the area under a curve by dividing it into the area into rectangles. Now, of course, there's going to be error in this. So here comes your engineering aspect. We're going to try to reduce the area later on, but the error later on, but we're going to focus on area. So first off, we want to consider the function y equals x squared. That's one of our favorite dudes. It's a classic parabola. Goes to the 0, 0, goes to the point 1, 1, 2, 4, negative 1, 1, negative 2, 4, so forth, so on. And we want to estimate the area under the curve between 0 and 2. Area under the curve means between the curve back to the x-axis. So here's my curve. Here's y equals x squared between 0 and 2. So we're talking about we want to estimate this particular area. That's what we're after. Okay? But what Riemann did was he put in rectangles. Now, but when you put in rectangles, you've got two choices. You can either use what we call left Riemann sums or right Riemann sums. Now, so I typed up this example for you, so I'm going to walk this one through with you. We're going to divide the area up into 4 rectangles. We chose 4. That is my n number to get used to the concept here. N equals 4 of rectangles, and they're going to be of equal length. So note that the interval is between 0 and 2, has been divided into 4 equal parts. Each part is going to be a half. That's a formula. To calculate your delta x, it is b minus a over n. A and b are your endpoints. N is the number of partitions or rectangles you want to put in there. So a is equal to 0 in this one. B is equal to 2. So this will be 2 minus 0 divided by 4. That's where we calculated it out to be a half. I mean, you can think about it. Yeah, it makes sense to equal parts. So if I got between 0 and 2 and I'm going to put 4 rectangles, each rectangle is going to be a half a meter long. You can think about the math, but there's actually a formula for this. It's called delta x, b minus a divided by n. So we start at 0. My delta x is a half, so I put a half. And another delta x will be another half. And it'll be at 1. Another half will be 3 halves. Another half will be at 2. And there's 1, 2, 3, 4 partitions. Okay? Now this is going to be called a left Riemann sum. Why left Riemann sum? Because you're going to look, actually, excuse me, this one's going to be a right Riemann sum first. Focus on this one. This one is a right Riemann sum. Right Riemann sum. Now why it's going to be a right Riemann sum? Because if you look at your width, we're going to use the end point on the right. So we got a rectangle here. Okay? So the point on the right is a half. And then the next one between a half and 1, the point on the right is 1. Between 1 and 1.5, the point on the right is 1.5. Between 1.5 and 2, the point on the right is 2. Now, we need to figure out the area of a rectangle. What's the formula for the area of a rectangle? It's length times width, right? The length of these guys, each one of them is 1/2 unit. The width is 1/2 units, right? But how do I figure out what the height or the length of this thing is? How tall is this guy? Well, we're based upon the function y equals x squared, or f of x equals x squared. So to figure out the height, you've got to plug in a point into the function to see how tall the point goes. We're going to use the point on the right. So if you look at this, for the area 1 right here, f of 1/2, that'll give me the height times the width of 1/2. and then clean it up. Well, the function is x squared, so 1/2 squared times a half. You clean it up, you get an eighth. This happens to be 1/8 units squared. That's how much area is in here. Now, for your next rectangle, I'm going to call this is area 1, this is area 2, here's area 3, and area 4. For area 2, it's length times width. Here's the length of it is 1/2. The height of this thing is, I'm going to plug in 1 into my function to see how high that is. That'll be f of 1, but the function is x squared, so 1 squared times the width, which is 1/2. 1 squared is 1 times 1/2 is basically 1 times 1/2, which is 1/2. This is 1/2 of a square unit long area. Now, between 1 and 1/2, we're going to plot 1.5 right here, and we're going to find the area of this rectangle. It's base times height, if you want to look at it that way. The base, or the width, is 1/2. The length or the height is going to be f of 3/2. So f of 3/2 times that base, which is 1/2. That's 3/2 squared, because it's f of x is the function squared. F of 3/2 squared times 1/2, that gives you 9/8. This is 9/8. And the last one is between 3/2 and 2. 2 is the point on the right, so to figure out the height, that'll be f of 2 times the width, which is 1/2. 2 squared is 4 times 1/2, and you end up being 2. This happens to be 2 square units. Now, to estimate the total area under the curve, we add up all the little individual areas. So we adding up area 1, area 2, area 3, area 4, that's an eighth plus 1/2 plus 9/8 plus 2, and I get 30/8. But here's my problem. Is this the exact area under the curve? No. If it's not exact, you got two options. It's either got to be an overestimate or an underestimate. Which one is this one going to be? This one's going to be an overestimate, and it's based upon the way the curvature is. This thing curves up, and it's because I used the point on the right, we overestimated. The rectangle is bigger than that true area under the curve. So it's an estimate, but it is an overestimate. Does that make sense? Okay? So this is called, like I said, a right Riemann sum, because between the two partition points, we use the point on the right to estimate the height of it. Similarly, a left Riemann sum, we're going to use the same curve. This is y equals x squared. But this time, we're going to use the point on the left for our left Riemann sum. So between 0, the width, again, is going to be in 4 partitions. So 0 to 1/2, 1/2 to 1, 1, 1.5, 1.5 to 2. Okay? So I'm going to use the point on the left for the left Riemann sum. So I'm going to call this area A0. This is A1, A2, and this is A3. And we're talking about the rectangles here. So A0, well, it's length times width. Well, that's f of 0. The function is 0 squared, so 0 squared is 0, times the width is 1/2. 0 times 1/2 is 0. So there is no area for this particular rectangle, because it's actually on the x-axis. Area 1 is the base, which is 1/2, times the height. We're using the point on the left, so f of 1/2. F of 1/2 is a 1/2 squared, because it's the function squared, times the width, which is 1/2. That gives you 1/8, so this thing has 1/8 square units. Area 2 right here, its base is 1/2, again, because they're all bases of 1/2. The width is at delta x 1/2. But now we're using the point on the left, which is 1, f of 1 times 1/2. So that's 1 squared times 1/2, which gives you 1/2. This is 1/2 a square unit. And this one right here, again, is a rectangle. Your base is going to be 1/2. The height, using the point on the left, will be at 3/2. That's what touches the function. F of 3/2, which is 3/2 squared times 1/2. That gives you 9/8. So this is area of 9/8. This is an area of 1/2. This was an area of 1/8. This had no area at all. And to get the total area, we add them all up, and we get 14/8. But again, is this the exact area in the curve? No, it's not exact. So if it's not exact, it's either got to be an overestimate or an underestimate. Which one's this going to be? Again, because the curve went upward and we used the left Riemann sums, we were only calculating the area of these rectangles, and there's lots of gaps between the rectangle back to the curve. This is going to be an underestimate. So to get a better estimate than that, why don't you just add the two answers together? And we can do that. You can take the left Riemann sum plus the right Riemann sum and divide by 2, and that gives you 11/4, and that's a better estimate of the area under the curve, but it's still not exact. But instead of doing left Riemann sum and right Riemann sum, because that's two different processes, and then putting them together to get an answer, what would be a better estimate would be something called the midpoint Riemann sum. Now, why would the midpoint Riemann sum be better? Well, again, you're going to use the midpoint from each partition. So this one I didn't type up for you guys, so let's work this one together. Your delta x, remember your function is x squared. Your bounds are between 0 and 2. So your delta x is b minus a divided by n, and our number of partitions was 4. We're still going to do 4 rectangles on this thing. So that's 2 minus 0 divided by 4, which is a half. So I start at 0, and I move over a half, and I put a mark. I move a half, move over another half, which makes it 1, put a mark. Move over another half, makes it 3 halves, put a mark. These are called the partition points, and between 3 halves, another half puts it at 2, and 2 is my end point, so I stop there. 1, 2, 3, 4 partitions. To get a better estimate, instead of using the left end point or the right end point of each rectangle, I'm going to use the midpoint. Now let's remind ourselves of what midpoint is. To find a midpoint, you've got to take the two endpoints, add them together, and divide by 2. So what is 0 plus a half divided by 2? The point in the middle is 1/4. That's between 0 and a half. What's between 1 half and 1? Add them together, that's 3 halves. Divide by 2, that's going to be 3/4. So between 1 half and 1, the midpoint is 3/4. You can catch a pattern on this stuff anytime you want to. Between 1 and 1 1/2, what's the next midpoint? 5/4. And between 1 1/2 and 2, add them together and divide by 2, you get 7/4. These are the midpoints. These are the partition points that I'm going to use for the midpoint rule. I got to find the midpoint of each partition. Does that make sense? Now, to figure out area 1, so this is going to be area 1 right here. You can barely see it because it'll be rather small. You got to take the length of this thing, which would be f of your midpoint, 1/4, times the width. The width of each partition is the same. That width is your delta x, times that delta x, which is a half. Well, remember, my function is x squared. So this would be 1/4 squared times a half. That's a 16th. 1/4 squared is a 16th times a half is what? 1/32? All I'm doing is crunching numbers in my head, so keep up. All right, what about area 2? Here's area 2. To figure out the area of this rectangle, f of 3/4 times its width, which is a half. Your function is squared, so 3/4 squared times a half. I'll do this math for you. 3/4 squared is what? 9/16 times a half. That makes it 9/32. That's what the area of that particular rectangle is. Area 3 here is going to be f of your midpoint to get the height on this thing, which is 5/4 times the width, which is a half. This is 5/4 squared times a half. That's 25/16 times a half. That's 25/32. And then your area 4 right here is we're going to figure out the height. You're going to do f of that midpoint 7/4 times the width of that rectangle, which is a half. This will be 7/4 squared times a half. 7/4 squared is 49/16 times a half, makes it 49/32. So to get the area, estimate the area under the curve, I'm going to add up area 1 plus area 2 plus area 3 plus area 4. And that's going to end up giving me what? Let's see here. 1/32 plus 9/32 plus 25/32 plus 49/32. Nope, time for a calculator now. So here we go. This will be 1 plus 9 plus 25 plus 49. They all have the same common denominator, which makes it 84/32. And for you guys that love decimals, this is 2.625. And for you guys that love reducing your fraction, this is also known as 21/8. And we are talking about area, so it's units square. So those are the estimate for the area in the curve. Now, I got a question for you. Is this, using this Riemann technique, using just 4 partitions, is this answer, 2.625, the exact area under the curve y equals x squared between 0 and 2, area back, meaning area under the curve back to the x-axis. Is this the exact answer? No. It's an estimate. So I have a question. If it's an estimate, it's either got to be an overestimate or an underestimate. My question to you is this. Which one is it? Overestimate or underestimate? Well, I got a 50-50 shot on this one then, don't I? But you'll notice by using the midpoint, it's harder for you to tell if it's over or under. But the real check is, look at this block right here. All the blocks are the same, but this one is probably more exaggerated. Look at area 3. Now, see what's happening with the midpoint Riemann sum is your errors are canceling out. See, half this thing, this is the overestimate part, right? And this is the underestimate part. Does that make sense? Now, on that particular curve, which one looks bigger? Is the overestimate bigger or smaller than the underestimate? They're canceling each other out, and that's what makes this a better answer. That's the key to this stuff. But which one is it? Which one, quote, looks better? Is it the underestimate looks bigger or the overestimate looks bigger? The underestimate. So this one is a slight underestimate. It's close, but it's not exact. But analyzing one of the curves, because they're all the same, but it's harder to see them. This one, the blocks are, and this one here, you can, yeah, I guess this one, you can see that's smaller than this one, but you get the idea. Your errors are canceling each other out. That makes it a better example and stuff. Okay? So, last thing before I let you guys go is this. What we're talking about here is a formula. All right? So, here is your formula for this. Left Riemann sum is this area equals f of x naught, because you got the two partitions. See, your delta x is b minus a over n. You break this guy up, even number of partitions, and you use the point on the left, f of that times your delta x, and add it up. And notice my formulas. For right Riemann sum, between x0 and x1, the point on the right is x1, so you do f of x1 times delta x plus f of x2 times delta x, and we have a formula for that. And then we have a formula for the midpoint. You add the two numbers together and divide by 2 and do f of that times delta x, and we call that x bar. So next time, when I finish this up, we're going to finish up these more examples, and the real trick is, how do I get better estimates? How am I going to get better estimates on this thing? More partitions is going to be the key. So instead of 4, do 8. Instead of 8, do 80. Instead of 80, do 8 million. It's great. The more you do, the better it's going to be. Study hard on this stuff, and we'll finish this up next time, and then go into section 5.2.